Welcome back to Salesforce AI Specialist, Certification Prep Tutorial. I am Santosh. In this lesson, we will cover the Einstein Trust Layer. The Trust Layer is the basis for all of Salesforce's AI applications. We will go over all components of the Einstein Trust Layer, and in the summary, we will re-emphasize some points that will be really helpful in your certification exam. The Einstein Trust Layer is a collection of features, processes, and policies designed to safeguard data privacy, enhance AI accuracy, and promote responsible use of AI across the Salesforce ecosystem. Trust Layer allows you to benefit from generative AI without compromising your customer data. At the same time, it lets you use trusted data to improve generative AI responses. Trust Layer also enhances the accuracy of AI responses by grounding your prompt with the company's data. It safeguards data privacy by masking sensitive information before sending it to LLM, and also instituting a zero data retention policy on the LLM side. The Trust Layer does all this by ensuring that your data is accessed securely, keeping Salesforce rules, permissions, and access hierarchy intact, and making sure that the prompts sent to LLM align with the policies of the organization. In addition, Trust Layer ensures that the employees use the LLM without bias or toxicity. It also monitors each interaction that the user has with the LLM by capturing event logs and using Audit Trail. How does Trust Layer accomplish all these features? Let us take a look. To enhance LLM accuracy, the Trust Layer uses secure retrieval and dynamic grounding. To safeguard data privacy, it uses data masking and zero data retention. To secure interactions with the LLM, the Trust Layer uses prompt defense. To promote responsible use, it applies Toxicity Detection. And for end-to-end monitoring, the Trust Layer uses Audit Trail. Main functionality of the Trust Layer could be divided into three parts. First part is the prompt journey. That path takes a prompt created by the user to the LLM. The second part is the response generation, which takes place at the LLM side. And the final part is the response journey, that readies the LLM output and delivers to the user. Now we will look into each of these components in detail. The prompt journey. You interact with an LLM using a prompt. A prompt is a set of instructions to elicit the best response from the LLM. Refer to Lesson 2 AI Fundamentals to learn about how a prompt elicits a response from an LLM. The prompt journey consists of creating a basic prompt, retrieving CRM data, grounding the prompt with the retrieved data, masking the sensitive information in the prompt, and adding system policy directions to the prompt, and sending it to the LLM. You use Prompt Builder to create the prompt, and to ground it. We will cover Prompt Builder in the next lesson. Now let us take a look at the other components of the prompt journey. Secure Data Retrieval and Dynamic Grounding. Let's walk through an example of generating a personalized email using a large language model for a specific customer. When generating customer emails with an LLM, personalization is the key, as it enhances engagement. You need to include customer-specific details to the prompt to generate a customized email. This process of adding context with your data is called Retrieval Augmented Generation, RAG, or grounding. Grounding ensures that the LLM generates content tailored to the customer. RAG is covered in detail in Lesson 2 AI Fundamentals. Secure Data Retrieval means that the prompt is grounded only with the data that the executing user has access to. The data retrieval process respects existing access controls and permissions in Salesforce. In Prompt Builder, you create a prompt and then ground that prompt using merge fields or flows with the CRM data. That data could be record fields, flows, Apex, Data Cloud DMOs, or related lists. The grounding is dynamic, since the grounding happens at runtime and depends on the user's access. Data masking. The Trust Layer masks any sensitive data before it is sent to the LLM. Identification of the sensitive data is the first step. How does Trust Layer identify sensitive data in the prompt? There are two ways it does this. First, pattern-based search, specifically, regular expression patterns and context words. Second, use machine learning to identify sensitive data that don't have a defined pattern, such as names of people or companies. If you have done data classification already in your org, using Shield platform encryption or data classification, that metadata is used for masking. Once identified, the data is then masked with a placeholder text to prevent the data from being exposed to external models. Einstein Trust Layer temporarily stores the relationship between the original entities and their respective placeholders. This relationship is used later to demask the data in the generated response. You can generate a standard data cloud report to verify the masking status of sensitive fields. The prompt defense. To help decrease the likelihood of the LLM generating something unintended or harmful, system policies are defined. When you build a prompt with Prompt Builder or Prompt Builder API, system policies are automatically included in the prompt. System policies are a set of instructions to the LLM for how to behave in a certain manner to build trust with users. For example, instruct LLM, do not address content or generate answers you don't have information about. System policies are one way to address jailbreaking and prompt injection attacks. Jailbreaking refers to bypassing or circumventing the restrictions, safeguards, or ethical guidelines built into an AI system. Prompt injection attack is a technique used to manipulate AI models by crafting prompts that force the model to behave in unintended ways. After a prompt is fully hydrated and secured, it's ready to be sent through the LLM Gateway. The gateway governs interactions with different model providers and represents a unified, secure way to communicate with multiple LLMs. The gateway and model providers use TLS encryption to make sure the data is secured during transit. We will learn more about models in the lesson Model Builder later in the course. This diagram shows the trust boundaries more clearly. Models built or fine-tuned by Salesforce are hosted in the Salesforce Trust Boundary. The Salesforce Trust Boundary is shown in solid line. External models built and maintained by third-party providers, such as OpenAI, are in a shared trust boundary. The shared trust boundary is shown in the dotted lines on the right. OpenAI is shown inside that boundary. Salesforce has a zero data retention policy with model providers such as OpenAI and Microsoft Azure OpenAI. According to this policy, no data is used for LLM model training or product improvements by third-party LLMs. No data is retained by the third-party LLMs. No human being at the third-party provider looks at data sent to their LLM. The data is deleted after a response is sent back to Salesforce. When the generated response is returned from the large language model, the Einstein Trust Layer applies certain policies and processes to make sure the response is safe and useful. Toxicity detection, data demasking, and feedback and audit trail are the main components in the response journey. To toxicity detection, the trust layer scans the generated responses for toxicity. The detection process includes finding a toxicity confidence score, which reflects the probability of the response including harmful or inappropriate content. The trust layer uses Salesforce Assessment Tool, a deep learning framework, to come up with a toxicity confidence score. A toxicity score of 1 means the response is safe or non-toxic. And a score between 0 and 1 means there is some toxicity in the response. The toxicity score and the categories are stored in the data cloud. To review toxicity scores, you can use standard data cloud reports. You can also use the pre-built dashboards and reports to review toxicity trends. Data demasking. This is the reverse process of data masking. The placeholders we created for masking the data during the prompt journey is now replaced with the actual data. The relationship between the original entities and their respective placeholders is used to rehydrate the response. Feedback and audit trail. The user can provide explicit feedback on response. In addition, Salesforce capture implicit feedback. Both are stored in your data cloud instance. Audit trail. Audit trail includes the original prompt, masked prompt, scores logged during toxicity detection, original output from LLM, and the demasked output. Audit trail data is also stored in your data cloud instance. How long is the data stored? You have control on how long the data is stored. Salesforce keep both the audit trail and feedback data for 30 days for compliance. In summary, the Einstein Trust Layer lets you get the benefit of generative AI without compromising your data security and privacy controls. It includes a toolbox of features like secure data retrieval, dynamic grounding, data masking, zero data retention, and toxic language detection. In addition, it adds accountability using audit trail. The trust layer consists of 3 paths: prompt journey, response generation, and response journey. You need to be familiar with the components of each path and the order in which it occurs. In the prompt journey, secure data retrieval and dynamic grounding is followed by data masking and prompt defense. In secure data retrieval, please note that the user can ground only the data the user has access to. Data retrieval follows the role-based access controls, permissions, and field-level security. Dynamic grounding happens at runtime. You could also ground data from external systems using Data Cloud. In data masking, the masking is done by replacing the data with a placeholder. The relationship between the placeholder and original data is stored, and it is used during data demasking. You can run standard data cloud reports to verify the data masking on sensitive data elements. Prompt defense prevents LLM from generating unintended content. It does this by using system policies. System policies are a set of instructions to LLM telling it to behave in a certain manner. You can define the system policies. Prompt defense also protect against jailbreaking and prompt injection attacks. In the prompt generation path, LLM Gateway, Trust Boundary, and Zero Data Retention are the key components. LLM Gateway decides which LLM or LLMs to send the prompt to. Salesforce-hosted models are in Salesforce Trust Boundary. External models such as OpenAI is in Shared Trust Boundary. Zero Data Retention means no data is stored by LLM or use that data for training purposes. The user data is deleted after the response is generated. In the response journey path, Toxicity Detection, Data Demasking, and Audit Trail are important components. In Toxicity Detection, a Toxicity Confidence Score of 1 means the response is safe. The Toxicity Confidence Score is generated by the Salesforce assessment tool. The score is stored in the data cloud. In demasking, the placeholders are replaced with actual data. The Audit Trail keeps track of the original prompt, masked prompt, scores, original output, and demasked output. It is stored in the data cloud. You can control how long it could be stored. Hope you enjoyed this lesson. We will see you in the next lesson, Prompt Builder.